more on zeros of a polynomial function. I'm going to use this slide header as a catch-all, and there are probably going to be a few different little videos that evolve over time because there's lots of little things, but I'm going to start kind of with the big thought, and there'll be a few little side thoughts. I don't have the essential questions because I'm just going to kind of throw several little topics at you that are all going to come under that header. So the fundamental theorem of algebra, don't care that you know the name, really just kind of pay attention and watch, and it's something we've already said. It says that if I've got a polynomial function, it's going to have the number of its degree is going to equal its number of zeros. And we've said that sort of. We said it a little differently when we were dealing with quadratics. And again, I'll revisit that in a separate topic, either in class or online. But if I have a 5th degree polynomial, I expect 5 zeros. If I have a 2nd degree polynomial, I expect 2 zeros. Now we've said in the past up to 2 zeros. So when we talk about the fundamental theorem of algebra, we have to say, but what we're saying is if there's a repeated one, they count twice. So for example, if I have this perfect square polynomial, it factors to this. Again, I'm writing it with a y instead of f of x, but it factors to x minus 3 squared. So its only 0 is 3. Its only x-intercept, the only place it touches the x-axis is 3. But it doesn't pass through it. It just bounces off of it. So those end up getting counted twice. And the reason they get counted twice is, right, they take care of both of our degrees, in a sense. So if I have a higher degree polynomial function, it's possible that my 5th degree polynomial function could look like, it could have one place that bounces off, so that takes care of 2, and then 3, and then 4, and then 5. So that could be my 1, 2, 3, 4, 5. So it only has 4 different numbers that are said, but this one counts twice. Right? So it just bounces off that x-axis. Those count twice. And before we go through and we actually find all the zeros of a couple of these, the other thing we need to say is there's some that come in pairs. So if we have any complex zeros, they're complex conjugates, they come in a pair. And we also have irrational conjugates that are going to be zeros, and they come in pairs. What I mean by that, if I have 2 plus or minus I, that's 2 zeros. Or if I have 3, the negative 3 plus or minus I root 7, that's 2 zeros, right? Because of the plus and the minus, and they always come together. You never have one without the other. Same thing if I have a radical. If I have negative 1 plus or minus radical 6 over 9, that's 2 different answers. Negative 1 plus 2 point something, that whole thing divided by 9. So those always come in a set. So if I have a 5th degree polynomial, And I'm going to start this problem on one screen, and then I'm going to go to the next one, because it does take up a little bit of room. If I want to find all the zeros of this function, then I'm going to know that, yes, I'm going to have 5 zeros, but it could be 5 rational zeros, it could be 3 rational and 2 complex, it could be 3 rational and 2 irrational, it could be 1 rational and then 2 of each of these other varieties. So lots of different possibilities. So when I look at this, I have a few possibilities. I can try to factor, or I can start finding possible rational zeros, and doing synthetic substitution. I think this one would be able to be factored by grouping some. So if you want to try that on your own, that would be a good thing. But excuse me, I'm going to go ahead and do some synthetic substitution. So let's talk about what are our possible zeros. Well, it's going to be factors of the constant over factors of our leading coefficient, which is 1, so I don't really care about it. So it's just going to be plus or minus 1, plus or minus 2, and plus or minus 4. So those are easy enough numbers to deal with. That's why I'm choosing to go ahead and just start with that. Okay, so I got us some more room, and so I'm just going to start trying synthetic substitution. Now remember that I'm going to need a few placeholders in here. So x to the 5th, x to the 4th, x to the 3rd, x squared, x, and our constant. I'm going to start with 1. Nope. -1. Let's change colors. There we go. So there's our first 0. So remember, now that we've factored out that first factor, x plus 1, or the 0 of -1, this is now x to the 4th, x to the 3rd, x squared, x, and our constant. So that's my new one. I don't have to go back to that 6th place synthetic substitution. I can use a smaller one. I have to try -1 again because it could be the kind that bounces off, but I can use this shorter version. So I'm going to try -1. Nope. So I'm going to move on to 2. There's another one. So there's our second 0. So far our zeros that we have -1, we have 2, we need 3 more. So I'm going to try one more round of synthetic substitution. Remember, now that this one was x to the 4th, this is going to be x to the third. So I'm just looking to see if this would be something that would be easy to factor. Plus 1x minus 1, or that was x squared, that would be 1x. Doesn't look like anything I'd want to try to factor, so I'm going to just keep going with synthetic. I've only done 2 once, so I need to try 2 again. Feels like nope, that's not the right number. Yeah, that's right. Because I was able to take this guy. So we've got 2. Nope, that's not going to work. Now we'll go on to negative 2. There we go. There's our third one. So now I'm down to a quadratic. This is x squared, this is x, that's 1. I know that's not factorable, but it's a quadratic, and so I'm going to jump to the quad formula. I know it's not factorable, so it's not going to be a rational answer. It's going to be irrational or imaginary, one or the other. If all I cared about was is it rational or is it imaginary, I could just do the discriminant, but I'm going to do the whole quad formula because I want to know the actual answers. So there's my quad formula. My values are going to be 1, -1, and 1. A lot of 1s. Negative b is -1, so that's negative -1. -1 squared minus 4 times a couple positive 1s over 2 times another positive 1. X equals 1 plus or minus the square root of 1 minus 4 over 2. So it's going to be imaginary. X equals 1 plus or minus square root of -3 over 2. Whenever you have that negative radical, my answer is going to be 1 plus or minus I radical 3 over 2. So those are my last 2 zeros. I think I missed one. No. Okay, so we had -1, we had 2. I'm back up at the top of the page here, going to make my whole list. I had -1, I had 2, I had -2, so that was 3. And then 1 plus or minus I root 3 over 2. So those are my 5 solutions.